Well, this is Dr. Frederick looking at these same numbers again. We're looking at these numbers that we did earlier. And we have computed the mean is equal to 6.17. What we want to do is take our values, which are x's, and subtract the mean from each of them. And so that's very easily done. In fact, what I did to get the mean in there is not just to type in 6.17, but to take the actual sum of the numbers divided by the n, and that way rounding is not a problem for me. And then I'm just going to say that is equal to this value minus this value, and then I'll copy that value, that formula, and paste it in all the way down there. And then hopefully the sum of the deviations is going to be equal to 0. It looks like this tremendously large number. It's actually a tremendously small number. And if we put it in number format, we can see that it's 0 when there's no decimal points. If we just keep adding decimals, we'll see that it is just really very, very small number, and it's just a rounding problem. We'll just round it to that many digits, and it looks like 0. Now, to do the variance, to compute the variance, you have to start with the deviations, and then we're going to square the deviations. Okay, and so all we're going to say here is equal to this value times this value. I'm going to do this all the way down. Now you have to do this by a computer on the exam. You won't have Excel, but that's all you do. Is first you subtract the mean from the x score. 1 minus 6.17 is minus 5.17. Okay, you square them, and you just have to keep track of them on your paper. You use a calculator, and then you're going to add them all up like that, and that is not the variance. That is the sum of the squared deviations. What do you have to do to get the variance is you now have to take that value and divide it by however many values there are. That's the variance. Okay. And what is the standard deviation? Well, first of all, let's just go back and remind ourselves what we want to do is to find the actual variance of this set of scores of this sample. We're not trying to predict any values in a population, so we don't need to make any sort of correction. So here, to get the variance, we just divide it by the number of scores that there were. Okay. And to get the standard deviation, you're just going to take the square root of that value. Okay. Now let's just check our work and see if this is correct. And we're just going to say this is equal to, we'll do it up here, this is equal to variance of a sample for B4 to B15, and see, it doesn't do it for us correctly. So you have to watch Excel, because whenever it's doing a sample, it's estimating a population. And so it's completely the opposite that you would expect it to be. I don't know how to tell you that, except you just have to learn what the difference is. Whenever it's taking a sample, it's estimating a population, so it always does n minus 1. And that's why you get confused. And then here it's just going to be equal standard deviation of a population, B4 to B15. Okay, so you get the same values that way. Now, I want to explain this again. The way that Excel does it, when it says P, it says, I believe that this is all the values that exist. That's why it calls it a population. And that's why it uses that P in the formula. When it's trying to estimate a population, it says it has a sample. And so it puts the S in there. And you're always ending up with a larger value when you're using a sample to estimate a population, because you're dividing by n minus 1. Okay, so this should satisfy both of those questions. I'll just put the same link on there. Again, we're going to take the squared deviations here, 115, the sum of the squared deviations, and to get the estimate of the population, we're just going to say that's equal to this value. Hold on a second. Now it should be right. Okay, now we're just going to say it's equal to this value divided by 12 minus 1. And you see now that we have the sample value estimate of the population. And just to take the square root here, sorry. Okay, we get the same values there. So let's just type it. This is a sample estimating a population. And this is just, oh, I see what it's doing. This is just a sample, not estimating a population. Okay. Which one is smaller? The actual variance of your set of scores is always going to be smaller than if you're estimating a population. Here you're dividing by n, here you're dividing by n minus 1. Here you're dividing by n minus 1, the denominator is smaller. And here you're dividing by n, your denominator is larger. Whenever what's on the bottom is larger, you end up with a smaller number. Okay. Okay. I think that's all I wanted to show you there. All right, thanks.